So today I'm going to go through some of the work we're doing on health economic models in R and Shiny, and how we can make those more transparent. Just a bit about myself. So as Raymond said, I'm director of Dark Peak Analytics. I'm a health economist. Background is a PhD in public health economics. I was at the UKHSA during the pandemic, and I'm a co-director of the R for HTA consortium. I really specialize and probably am best known for being the guy who's kind of shouting into the void a few years ago about the use of R and script-based models for health economic evaluation. But as I'm going to touch on later, this is increasingly not shouting into a void anymore, and it's very much gaining a huge amount of traction. So I think the fact that there's lots of people on the call kind of shows that, and tons of people interested in this space. So in terms of kind of my background in this and my small role, back in 2019, Paul Schneider and I co-wrote a paper on how we could make health economic models using Shiny and make them deploy them online and make them available to people to interact with and to understand the models. We co-authored this open access paper in Welcome Open Research, which, if you're interested in this topic, is worth having a look at. And it gained immediately a huge amount of traction, a huge amount of interest. People who said, yes, this makes sense. Let's collaborate and let's do stuff together. And so from that, we essentially started Dog Peak Analytics, and it's the kind of bread and butter, the main thing that we do day to day. We built a short course off the back of it. Um, and that's been really popular with hundreds of delegates around the world joining, and we really enjoy the teaching and hearing about the different projects people are going to build their apps for. From that, we moved on after that initial success. We moved on to thinking about how we could automate out some of the health economic evaluation processes and make them more transparent in a kind of living HTA process. And that really fell flat. Back in 2022, we kind of tried to pitch it, and we introduced all these things around data security and sending models to remote servers to run the models on company servers so that they didn't have to share any data, and it really just fell flat. Didn't get a ton of interest. Um, and so we went from there and built out another tutorial paper onto how to work with models and how to build up models as R packages. And that's been moderately successful. It's much more advanced as a topic, and we've recently just converted the paper into another short course to make it so that if somebody did want to go away and build their model as a package and then share that with others, they would have a good set of resources to be able to go away and do that. Um, and then I was involved in reviewing an enormous R model for NICE, and very quickly realized that this was a huge amount of work, and so built an R package to improve the quality assurance process for health economic models, and that's called a CertHE, and is now on CRAN and has been used for a large number of models to kind of understand how the model works and use large language models to review small components of the model one at a time. And then this year at RHTA, we presented some work on how we can automate out some of the health economic evaluation reports that are required. So this kind of was a repeat of what we did back in 2022, which fell completely flat. So this work back here on Living HTA, which just got no interest at the time, suddenly is everybody's interested in this, potentially with the new kind of changes with JCA, but also with the integration with generative AI tools to help that writing process. And so we built an R package called Bibby, which is now open source on GitHub to help facilitate that process of pulling through kind of sources from input templates. So the sources for each parameter, pull those through into reports and automate out new reports for example, a country adaptation or anytime you change the source on a parameter in an economic model. So it's kind of a bit of a history of the weaving tour that we've taken and where we've seen the interesting success and the areas that we've not seen quite so much success. Um, in terms of the background for today, I show this slide at pretty much every talk I give because it's kind of the overarching sort of reason and impetus for what we're doing. So I make no apologies for those of you that have seen my presentations in the past and probably are sick of this slide. Um, but really, what we're trying to do is move away from the current process we have now, which involves individuals and groups working on understanding the inputs, working on statistical analysis of uh, trial data or costing data, or utilities, whatever it may be, and then feeding through those results of that analysis into the model as inputs. And often that will involve some copy and paste process to input in, shape and scale parameters or whatever it may be into the model in Excel, and then run that model potentially using VBA or equivalent. Then those outputs might be generated as plots on different tabs or in potentially even a different Excel file I've seen sometimes, crazily enough. And before the report is written, and those plots are copy and pasted into the Word report. And then a presentation is given, potentially using PowerPoint or equivalent. And so there's another round of copy and paste, either from the original model or potentially from the version 12 of the Word report. And so what we're looking to do is move away from that and towards a process where we've got a pipeline of data, starting from our initial statistical analysis and feeding the outputs of that directly through into a health economic model, which feeds directly through into plotting functions, which feed directly through into an automated report with R Markdown or now increasingly Quarto, and which all can be visualized in a user interface using Shiny. And so this is kind of where we're looking to go, primarily, and really the main reason is fairly boring. It avoids a huge amount of copy and paste, and it avoids a huge amount of human error, and means that we can change the turnaround time from days and weeks to seconds. And so I think I've shared this slide at ISPOR last year. Um, when we're looking at how we best achieve this, what types of software do we use? Um, when we compare spreadsheets and script-based models like R or Python, and I'm definitely not one to necessarily say that R is better than Python as such. That's a separate conversation I'm sure we can get into later. But when we compare those two, the capabilities of R in terms of how flexible it is at undertaking different types of analyses, combining with other open source packages like Shiny, like Markdown, to generate reports or to generate user interfaces, the visuals it can generate, the ability to run code and integrate with other algorithms and programming languages like Python or Julia. R just gives you that much more flexibility. It looks better. We've had in the past projects where essentially the primary reason for the client coming to us has been because they wanted the outputs to look really snazzy. And it took us a while in the project to realize that, but actually the outputs from R look really good. And we had an app a while back that we were running where people could just paste the outputs from their Excel model into the app and generate a plot for the SEAC or cost vectors plane in R. It really does make things look nicer than they do in Excel. Um, but really importantly, it's way faster. The computational speed when you're working with R, especially if you're able to work with R and C++ via a package called RCPP, or if you're able to deploy your model online on a remote server and run it in parallel on 200 cores, suddenly things that would take days to run can take seconds to run, which when combined with the user interface in a meeting can be really, really powerful. So we're not waiting for analysts to go away and write a report over the course of a week. We're getting answers to questions in real time. It's also much quicker to develop models. And this is something that I've had pushback on the past, and I'll touch on again in a minute. But once you've developed a few of these models in R, you'll realize that ultimately a lot of the functionality is just repeated between models. And because of the way R is built and the way you build a model in R, everything is modularized. And so you're just reusing small modules between models in much the same way as the Excel templates are kind of often created and sheets copied and pasted. But this is just much more efficient in a script-based model where you can copy a single function over and utilize it kind of going forward. And so it's just much easier to scale as well. So you can pass through lots of different country data into a model in ways that are just much easier than working with Excel. And what I'm going to focus on today for the talk is the transparency component. And I'm going to try and make the argument that it is much more transparent. And hopefully by the end of the talk, I'll be able to have convinced you of that and understand kind of why I think this really is where the key one of the key benefits of R is. And just to say, learning to code from scratch is hard, and I think this is the biggest problem with this transition from Excel to R is just the familiarity component and the barrier to entry of retraining huge numbers of people in a completely new skill set. And I think this is really where it is tricky. R has a very steep learning curve. Many people have not learned it at university, and things are improving, but coding in R is very hard. And so when I'm discussing now kind of the transparency component, it's worth thinking about what kind of platforms and use cases we have in mind. So generally, when we're working with models and when we're reviewing models, the primary programming language is R, often with a little bit of C++, Python, and some other software scattered in there where they're interoperable. And generally, the code that we're reviewing or working with is hosted on a platform like GitHub. There are other providers, there's GitLab, and some things are on Zenodo for publications, but primarily we're working with a model in R, and it's on GitHub. So with that in mind, when a modeler is developing their R model, one of the really nice things is that we can separate out the source code from the model. So that might be the functions that we've developed to run our model, and alongside any openly available data that we're not concerned about sharing, we can separate that out from any sensitive data that can be stored completely separately in a separate folder, only available to a select number of people. And so the modeler can go in and work with that and develop that over time. And then a report can be generated from that using that code and that data and sent to NICE or for an academic publication or whatever else it may be. And so then what do we mean by transparency? So for some types of reviewers, for example, an ERG or any other reviewer, they may require access to the code, any open data, and any sensitive data, so everything essentially. And they might be really interested in the technical detail of exactly how every algorithm is being run and how that feeds through in the sensitivity of the model. So they're really going to go into the detail on everything. But what's really nice about models that are built in script-based programming languages and shared on GitHub is that there's no real reason why a separate reviewer, without access to any sensitive data, couldn't just review the model code. So without any sensitive information, they could just review the model code and potentially identify a whole range of bugs and issues with the model without ever having access to the data, which is a really big advantage of these script-based models. And a final use case might be reviewer 3, who might not be interested in digging into any of the data, might not be interested in the code. They just want to understand the implications for policy. And for them, a graphical user interface, like those developed with Shiny, is probably the most useful kind of way to access the model. So for reviewer one and two, we absolutely need those people. We need those people who can code, who understand the details of R, understand how these models are built and how they're structured and how the algorithms work. And to do that, we've built a whole series of courses on Introduction to R for health economic evaluation. And we've also developed open source software that I mentioned earlier, AssertHE, to try and help reviewers review models in a way that in a way that means that they can understand what's going on really quickly and kind of ask questions of a Gen AI tool like a chatbot to ask questions about the model itself. But this has also become essential. Being able to develop these user interfaces in such a way that they're usable, they're intuitive, and people can get the information they need quickly and understand it and the implications of different parametric assumptions. And so we've developed the paper and the short course on Shiny, which has been really useful for trying to build kind of capacity in that space. So focusing now on how we can do that and how we can make these models more shiny. There's a really nice quote from Professor Chris Whitty, who in the UK was the chief medical officer during the pandemic. He says that authors of modeling papers can do things to make their work substantially more useful for policy. The best is to provide an interactive interface where if the policymaker does not agree with the starting assumptions of the model, they can change them. And what he's talking about here is from a policymaker's perspective, often when reading reports, there'll be something in the report in the assumptions of the model that that policymaker disagrees with. And often you'll lose the policymaker at that point. And so they'll stop reading. They'll throw that, put that report aside or throw it in the bin and say, I don't agree with that. They've made some tenuous assumption. And that can either result in a huge amount of work being redone, as I mentioned before, people saying, can we do some extra sensitivity analyses? Can we do this? Can we do that? And people waiting a week or months to get that report back, by which point the window for policy change has potentially shifted. But increasingly, what we're seeing is giving policymakers the ability to play with parameters and run models live. And my experience has been, especially with politicians, but decision makers across a range of industries, is that giving the power to the decision maker to change some of those default parameters, potentially within a kind of credible range that's been preset, so as not to do something crazy, but to change those parameters and realize and understand maybe that parameter doesn't actually make as much difference as they thought, or actually we need to have a discussion about that parameter, has been really, really valuable. And so the question comes, if this is kind of the way forward and the way that models are going to be shared, how do we do that? And from my experience, the way that this is typically done is you need someone with domain knowledge, someone who's gonna shape the project, lead the project, and manage all of the assumptions, all of the kind of modeling process, and that's ultimately a health economist. Somebody needs to have programming expertise. That may be the health economist, it may be a programmer who's going to help with the project. You need someone to understand little bits of data architecture. Often for the models that we're building, there's not that much data, so it's not a huge task, but still they need to understand how to ensure that data remains secure, and how to ensure that everything kind of feeds through. You definitely need a UI UX designer, so someone who understands the basics of how can we lay out a interface in such a way that it's useful to people, that people can navigate through it, that people don't have to ask a million questions every time they use the tool. And ideally, you'd have a project manager to fit all this in. But really, the crucial person is that health economist. Without that domain expert, the whole thing just falls down, and the rest of the team will struggle to add the value there. And so that's why we originally published the paper, really targeted towards how can we give health economists the absolute kind of minimum grounding in a lot of these skills. So a little bit of UI stuff, a little bit of understanding about the data, a little bit of understanding about how to program the model, just enough so that if they can lead the project and kind of rely upon the expertise of others in a team to kind of polish the app, make it look really fancy at the end. But really, this needs to be driven by the health economist. And so, after having made this paper available, we also built the online short course, and then developed a whole series of case studies. So there's this openly available case study app which kind of goes through the process of fitting survival curves to Kaplan-Meier, adding custom utilities, um, outputting plots, downloading plots, sending summary reports to people via email, and utilizes a kind of faster method of running time-dependent Markov models using C++. And so what would typically be a very slow process, so a time-dependent state transition model in Excel might end up, sometimes I've seen them take hours, runs in around 4 seconds. And so suddenly you have something that's really useful for decision makers live. We've also had projects in an increasing number where somebody's built a model in R and somebody else wants to review it but doesn't understand R. And so we've taken the model and built a wrapper, really basic, really quick and dirty, as you can see from here, nothing super fancy, just a really, really basic UI, just to show kind of some key results and understand sensitivities within the model. And that kind of thing could be really useful for internal decision makers just to sense check a model very quickly. We're also working with R and script-based models because of the ability to work with large data sets and diffuse data sets across different sectors and use APIs. It's meant that we've been able to work with different types of data. So we presented yesterday on our geospatial health economic modeling work, where we're looking at alongside the cost effectiveness, how can you estimate how and where to create new healthcare sites to maximize different objective functions around treatment adherence, improving travel distance and access to care for different groups in society. And so this kind of thing just wouldn't be possible in Excel at all. And obviously having the interface makes it far more reachable and accessible for different stakeholders. Some of you might also be aware of the other tools that are out there. So there's a nice tool for distributional cost effectiveness analysis that Paul built. Paul and I uh, co-founded DocVeek Analytics years ago, and Paul built this one with the University of York, looking at essentially a tool to plug in the results from models and understand the distributional effects of those models. So we're kind of seeing an increase not only in the use of or the integration of models themselves, but also tools to augment the modeling process. So to do certain tasks so that people who are not familiar with R, so for example, there's a package and a series of scripts behind this that if somebody was familiar with R could just build in themselves. But if somebody's not familiar with R, you could use a user interface to make those methods and those algorithms more accessible. Very similar thing for the shortfall tool, also hosted by York. So a very similar thing there, looking at quali shortfall, and there's a whole series of R scripts and algorithms and functions to achieve these calculations that can be built into any R model in a matter of minutes, just calling those functions. But for those that aren't working in R, who might be working in Excel, they can go and plug their values in into this online tool with Shiny, and then get their results that they need for their model. We've also been using it for training tools. So this is an example of a training model that we developed to help teach people who are new to health economics the core concepts of health economics. So this one is a PSA. This page is explaining what probabilistic sensitivity analysis is. And what's really nice is it's interactive. So as well as some information, some links, and kind of further reading, it also gives the user kind of something to play with while they're learning and do some kind of questions and things as they go. And last one, before I stop going through a ton of case studies, is the tool that we've been developing for structured expert elicitation, which allows you to do some work on long-term survival extrapolations incorporating expert opinion. And so kind of all of these tools are gradually building up this ecosystem where we can do a ton of stuff that otherwise would have had to be done in R scripts by statisticians and modelers. Can now different steps can be done either via a Shiny app tool or for those that can code in R, just directly in the package. Um, and finally, just to say that one of the nicest things I've seen is that as we kind of have taught this course over a number of years, we've had lots of the delegates kind of share one their app at the end of the course that they have them develop and deploy online, but also share some of the work that they're working on. So we tend to get a couple of emails so every month or so from someone who's published a paper and then been able to make a user interface available for their model, which is really nice for us to be able to share those. Okay, so I'm about right on time, but I'm just going to talk briefly through some new developments. So the use of these user interfaces is become increasingly more common, um, in part through the work of our HTA and other groups, in part through our courses, and in part just because gradually over time people are realizing the value. And so where we're trying to kind of push things and build on